Hey, what's up? When I initially looked at this problem yesterday, I wasn't able to do it, but I've been thinking about it all day, and I think I came up with something on my commute. So let's take another look here. Leetcode 3347, maximum frequency of an element after performing operations. Number 2. You're given an integer array nums and 2 integers k and num operations. You must perform an operation, num operations times, on nums, wherein each operation you select an index I that was not selected in any previous operations, add an integer in the range negative k to positive k to nums I. Return the maximum possible frequency of any element in nums after performing the operations. Okay, so example is 145, k is 1, num operations is 2. We can achieve a maximum frequency of 2 by adding 0 to nums 1 and adding -1 to nums 2. Now, having to apply more operations isn't a problem because we can choose to add 0. Now, the idea that I had while I was driving initially, and this wasn't going to work, was you actually calculate for each value how many things that there are for that specific value. And the first thing you notice here is there's just no way to look at the entire range. It's not feasible. However, it is possible, obviously, to look at every value that's in here. So what I think we need to do is we just need to figure out what the relevant values are. And it seems like numbers and between numbers are what we need to look at. We need to look at the maximum and minimum from any number, because those are the only ranges that could possibly matter. And the most we could possibly get is 3 times 10 to the 5th. With some exceptions for the edges. So let's say important numbers equals nums. Well, equals set of nums, right? And then we will say for I in nums, and then we'll say important numbers dot add let's do it this way. Nums.sort, right? And then we will say the minimum and the maximum are nums 0 and nums -1, because we're going to need it sorted later anyway. Okay, so we're going to do the max of the minimum value and the current value minus k. And then important numbers is the minimum value of the maximum and I plus k. Because there's no reason to go past the largest number or less than the lowest number. It just doesn't make sense. So now I think what we need to do is we need to maintain a list of things that are in range. And yeah, I think we should be able to do it with 4 pointers, right? So we're going to do min in range. What I don't know. Max in range. And then do we have to maintain the current number or not? I feel like we do. Okay, we're going to call this min inclusive and max exclusive, right? And these are both going to be 0. Yeah, because there's nothing in there yet. And then we are going to say current number inclusive left, current number left inclusive, and then current number right exclusive. Okay, and that will also be 0, 0. And then we're going to say mi inclusive is lesser than or equal to cnl underscore inclusive is lesser than or equal to cnr exclusive is lesser than or equal to maxc. So it's going to be a quad pointer thing. So let's look at the important numbers in order and then try to determine what will work. It's okay, so we're going to say best equals 1, obviously. Obviously. So let's go for I in sorted important numbers, right? Now we have to adjust our pointers accordingly. So while mi inclusive is less than current number minus k, because we can't, am I doing that right? Am I doing that right? Yeah, because it points to num. But it's not minimum inclusive, it's, excuse me, I'm sorry. I knew that something was wrong. Nums of minimum inclusive is less than the important number minus k. Because that means we would not be able to arrive at that number. And then just every one of these should be advancing to the right because we are going in sorted order. So yeah. Now we have to do the logic for each of them separately. So, okay, Cn of L inclusive. So, Cn of L inclusive is lesser than I. So long as it is lesser than I, then I got that already. That was already in the clipboard, so yeah. Okay, so if I is in there, then this should be the first instance of it. First instance of I if I is in there, otherwise first number greater than I. All right, now we are going to have MA exclusive equals that yeah, because it's going to be changing every time. So we don't need to worry about the old value. So now this is going to be MA exclusive. So, and this is going to be pushing to the right. So we might need to, I'm thinking, do we want to put a giant value on the right? So we don't have to worry about overflow. And I think but that's dumb. So length of nums, and I believe that'll short circuit. So MA is lesser than or equal to I. So this should be the first number strictly greater than I, or the end of the array. Right? Okay, this is our quad pointer here, so hopefully I haven't screwed anything up yet. MAX, did I use the wrong thing? Oh my god. I think I did. Minimum exclusive, CN left inclusive, MA, yes, this was supposed to be. This was dumb. This was so dumb. Okay. So current number, right, exclusive, first number greater than I, or end of array. Now we do, I'm sorry about that. MA exclusive is lesser than length of nums and is lesser than I plus K. And it's exclusive, so it's lesser than or equal to. Right? So we are going to the right, and then this. So first number greater than I plus K, or end of array. Now, I really hope I didn't make a mistake. I'm not going to spend the next 3 hours on this. If I made a mistake, I may do something crazy like ask ChatGPT to check it, but I'm going to try it on my own first. We're already a day late for getting this as the daily Leetcode. Okay, so for I and okay, so now we have our 4 counters. Now we need to figure out what we can do with them, right? So num operations is by definition going to be lesser than or equal to the number of items here. If num operations is equal to 0, well, that's an interesting case. Oh, no, well, we'll deal with it. So, yeah. So, how many things can we make I equal to I with given constraints? Right? Yeah. So, non-equal subset equal. Oh, this might be easier than I thought. Let's do equal subset equals, and this is where them being exclusive is helpful. Right exclusive minus left inclusive. So, in other words, already I. And then non-equal in range is going to be equal to max exclusive minus min inclusive. Okay. Here's how we're going to do it. Num allowed equals num operations plus equal subset, right? That doesn't change the number that are in range, only the number that we can access. And then we are going to say B equals max of B, and then the min of the num allowed and the it's not non-equal in range, it's just in range, right? Yeah. All right, let's see if that works. Let's pray. Oh. Well, so far so good, but I haven't tried it on any harder ones yet. Okay, let's go. Woohoo! First try. Well, not technically the first try. I looked at it last night and I've been thinking about it all day, so. Okay, I'm really glad I didn't have to rely on an LLM, but I was very nervous I was going to make a mistake in here. So, you know what? That was actually kind of fun. Yeah, whatever. See ya.